Hello students, in this session let us solve this question of moment of inertia. The given figure shows a T-section of dimensions 10 by 10 by 2 cm. We have to determine the moment of inertia of the section about the horizontal as well as vertical axis passing through the center of gravity of the section. We have to also find the polar moment of inertia of this T-section. So this is a question of T-section where dimensions are given 10 by 10 by 2 centimeters. We have to find the moment of inertia of this T-section about the vertical as well as horizontal section passing through the centroid, and we have to find the polar moment of inertia which is at a plane perpendicular to the x-axis and y-y axis. So let us solve this problem. In this question we are given with a T-section of different dimensions, and we have to find the moment of inertia of this T-section about the centroidal axis, right? I-axis and I-y. Basically we have to find out I-x-x and I-y-y from the centroid of this section, and also we have to find out the polar moment of inertia which is about the perpendicular of these two axes. This is IZZ, right? So first of all, find out the centroid. We have to find first of all the centroid of this section, right? So centroid, we have to assume that there is some point here where the centroid is passing. Suppose centroid is passing through this line, and this is our x-axis, right? And in this line, vertical line, the centroid will be passing through from the center of this T-section because of symmetry. Half portion is on this side, half portion is this side. So YY line will be passing through the center only, right? Because of symmetry. So this is YY axis, and this point is the centroid of this complete figure. G is the centroid of this complete figure, right? And this figure can be divided, and for finding the moment of inertia, we can divide the whole figure into two parts. Suppose this is one part, this is second part. Each part having its own center of gravity. So it is having some center of gravity, suppose here at the center of this rectangle. This is G1. This is also having center of gravity, centroid, somewhat here, suppose here at the center, like this. This is G2, right? So if the total height is 8 centimeter, then take the reference line to find out centroid. We can take as reference line. So let us see this is the reference line from where we can find out the centroid, the distance of the centroid. So this is our reference line, suppose, and this is the one of the tip of the T-section reference line, and this is our centroid from this reference line. Say this is y bar in y direction. This is say y bar, and this is the centroid of second figure EFGH. This is a centroid, and say this is y2 because it is second figure, and this is the centroid of section 1, like this, right? There is a centroid of section 1. So this is, say, figure 1 is here, so this is y1, right? So centroid of figure 1 is y1 from the reference, centroid of figure 2 is y2 from the reference line, and centroid of the whole figure T section is at G point, which is at y bar from the reference line, and the centroid in vertical direction is passing through the center only, right? So there is no issue. We have to find y bar first. Y bar, you know that y bar is given by the centroid is given by a1 y1 plus a2 y2 upon a1 plus a2. This formula is known to us. So this will be equal to area of section 1. Area of section 1, this section. This is 10 multiplied by 2. So 10 multiplied by 2 multiplied by y1, this is, how much is this? This is 8 plus 1, because it is 2 centimeter, half of 2 plus 8. So this is 9 plus a2, area of 2. This is 8 multiplied by 2, 8 multiplied by 2 multiplied by half of 8, that is 4 centimeters. This is 4 divided by total area. Total area is a1 plus a2. So this is 10 multiplied by 2 plus 8 multiplied by 2. So by this we can find out the centroid from the reference line in vertical direction, right? So this y bar will come out to be 6.78 centimeter from the bottom line or reference line, right? From this line, 6.78 centimeter. Now find out Ig1 and Ig2. If we want to find out the moment of inertia about x-axis, this x-axis, which is passing through Ig, we must know the moment of inertia about Ig1 and Ig2, and then we can apply the parallel axis theorem, right? So what we can do is we can apply the parallel axis theorem. This Ixx will be equal to Ig1, Ixx will be equal to, passing through G is I, moment of inertia of body 1, G1, plus apply the parallel axis theorem, that is area multiplied by perpendicular distance. So A, area of body 1 multiplied by square of the distance between the two centroids, right? So this is G1, distance G1. So this is G1 square, right? This is the Ixx, the moment of inertia of this body 1 about G, plus Ig2 plus A2 multiplied by this distance G2 square, this distance, right? So we can apply now Ixx will be equal to, these two terms are there, Ig1 for the time, or you can put directly the values, Ig1, that is BDQ. So suppose somewhat more we can simplify here, Ig1 plus area A1. What is Gg1? Gg1 is y1 minus y bar, from the reference line we know. So this is y1 minus y bar whole square, right? Plus I G2 plus A2. What is Gg2? This is y bar minus y2, square, right? So from this we can find out the moment of inertia about Ixx. So Ixx will be equal to, that is equal to Ig1 BD cube by 12. So BD cube by 12 is, D cube is of this, BD cube, 10 2 cube, 10 multiplied by 2 cube by 12. This is Ig1 plus area of A1, that is 10 multiplied by 2, 10 multiplied by 2 multiply y1 minus y bar. What is y1? This is known to us 9 centimeter. If we take in centimeter, everything in centimeter we are taking, so let us take in centimeter. So 9 minus y bar is, we have obtained 6.78. This is Ig1 plus y1 minus y bar square plus Ig2, that is BD cube by 12. So B is 2 and D cube is 8 cube, right? So B is 2, D cube is 8 cube by 12 plus this is Ig2 plus A2. A2 is the area of this figure. 2 multiplied by 8 multiplying y bar minus y2. Y bar minus y2. So what is y bar minus y2? So y bar minus y2 will be equal to, y bar is 6.78 minus y2. Y2 is, that is 8 by 2, that is 4 square, right? So this is now just a calculation left, and you can find out Ixx, the moment of inertia about x-axis, and that will come out to be, after calculation, calculate it and get the value of Ixx, that will be 314.2 centimeter to the power 4. So this is one of the answer. Moment of inertia about x-axis passing through centroid of the section, right? So this is 314.2 centimeter to the power 4. Now we want to find out Iyy, because it is already passing through centroid. So we have to just find out Ig1 and Ig2 passing through Iyy, right? So Iyy is very simple to find. No need to find out to apply the parallel axis theorem. We have to use only centroidal axis, because it is already passing through this line. Yy is already passing through the centroid, right? So we have to apply only Ig1 plus Ig2, right? So this will be equal to, BD cube by 12 Ig1. Now D will be reversed, it will be changed. Here it was 10 multiplied 2 cube by 12, it will be reversed 2 multiplied by 10 cube by 12, because D is now changed. So because we are taking the y axis now, right? So this will be equal to 2 multiplied by 10 cube by 12 plus Ig2. This is 8 multiplied by 2 cube, 8 multiplied by 2 cube by 12. So from here we can find out Iyy. So Iyy will come out to be, solve it mathematically and get the answer. So what is the answer? Iyy. So Iyy will come out to be 172 centimeter to the power 4. So this is one more answer to this question. One more answer to the question. One answer is Ixx, another answer is Iyy, right? Next we want to find out Izz, the polar moment of inertia. Izz, the polar moment of inertia, also called J, we also define it J, and that is the perpendicular axis theorem, that this is equal to Ixx plus Iyy, simply. So polar moment of inertia will come out to be Ixx plus Iyy, that is 314.2 plus 172. So J will come out to be, solve it and you will get the polar moment of inertia, and this is 486.2 centimeter to the power 4. So this is the last answer of this question, right? So how we solve this question? We have a T section. We have divided this T section into two parts. One is upper rectangle and another is the web part of this T section, right? And this is the flange part of this T section. And then we have taken the centroid of this each, and we assume that the centroid of the whole figure is passing through this point G. And then we have used the parallel axis theorem to find out Ixx, because Ixx is not passing through the centroid of the body. That's why we have to use the parallel axis theorem. We have used a parallel axis theorem here, and then apply the calculations and use the formula. For Iyy, there is no need to use the parallel axis theorem, because the axis is already passing through centroid. So that's why Ig1 plus Ig2, and we have found out Iyy, and finally we got the polar moment of inertia using the perpendicular axis theorem, that I z z will be equal to I x x plus I y y, and you will get the final result.